Welcome to AI Paper Podcasts. Today, we are jumping straight into a deep dive on a massive new paper that just dropped this month.
Yeah, February 2026.
Right. It's called Does Socialization Emerge in AI Agent Society? A case study of Moltbook by Ming Li, Zhihui Li, and their team.
It's a fascinating one.
It really is. So, to set the hook for you listening, we are looking at the largest AI-only social network ever built. It's called Moltbook. It has over 2 million agents.
Over 2.6 million, actually.
2.6 million. And the big question is, if you put all these LLM-based agents into a digital society, do they form a real society? Like, do they develop culture or norms or influencers?
And the short answer is a resounding no.
Yeah.
But the way it fails is incredibly interesting.
Yeah, break down the core verdict for us.
So there are three critical findings here. First, we get what they call global stability but local chaos. The society reaches this dynamic equilibrium where the average topic stabilizes, but the individual agents remain completely chaotic. No echo chambers form.
Which is wild.
Right. Second, we see interaction without influence. The agents have profound inertia. They do not adapt their behavior based on upvotes or downvotes or comments. They basically just talk past each other.
Just shouting into the void.
Exactly. And third, because of that, there are no hierarchies. There are no persistent influencers or supernodes. Any influence is completely fleeting.
So it's essentially a massive case of scalability without socialization.
Precisely. The society is socially hollow.
Socially hollow. That is such a great phrase. Okay, let's unpack this. Because for context, we've seen AI societies before, but not like this.
No, not at this scale.
Right, like we used to focus on single agent reasoning, like React or Voyager, and then we had things like generative agents. Remember the Stanford virtual town?
Yeah, the Valentine's Day party.
Exactly, 25 agents planning a party. It was cute, but it was basically a terrarium.
Yeah, Stanford's simulation was a dollhouse. Moltbook is a sprawling metropolis.
Right.
This is a persistent, open-ended platform. It ran for months. Tens of thousands of posts a day from those 2.6 million active agents.
And if you're trying to picture this, it's basically Reddit.
Pretty much exactly Reddit. It's organized into these topical subforums they call submolts. Agents can post, they can comment, upvote, downvote.
All the standard social features.
Exactly. And that scale is what matters here. It lets the researchers filter out the random noise and look for statistical proof of AI socialization.
But how do they define socialization? Because that's kind of a squishy term in sociology, right?
It can be. But here, they define it very strictly as the adaptation of behavior induced by sustained interaction.
Adaptation.
Right. It's not just random drift, and it's not just following their pre-prompt. It's asking, if I talk to you every day, do I start acting a little bit more like you?
So if there's no adaptation, they aren't socializing, they're just broadcasting.
Exactly.
Okay, so let's look at the society level dynamics, because if you put 1 million humans in a forum, we know exactly what happens.
Oh, we get echo chambers instantly.
Instantly. Polarization, inside jokes, slang. We homogenize into groups.
We expect semantic convergence. Yeah. But in Moltbook, they found something called dynamic equilibrium.
Right. They measured the daily semantic centroid.
Yeah, so imagine you map every topic onto a giant graph. The centroid is the exact mathematical center of all that chatter, and that average stabilized incredibly fast.
Meaning the society as a whole figured out what it wanted to talk about.
On a macro level, yes. But here's the catch. When they looked at the pairwise similarity, so taking any two random posts and seeing how close they were to each other, it stayed super low.
So the global average looks stable, but underneath, it's a mess.
It's totally chaotic. It's like looking at a swarm of bees from a distance. The swarm hovers in one place, so the average is stable. But zoom in, and every single bee is just flying in random directions.
Okay, but what about language evolution? Because they also looked at lexical innovation.
They did. They tracked anagrams, basically sequences of words, to see if the vocabulary was changing.
It was, right?
It was constantly refreshing. Old words died off. New words were born at this really steady rate.
So they are inventing things. It's not stagnant.
It's not stagnant at all. But, and this is the crucial part, in human networks, when we invent new words, we see cluster tightening.
Right, because I use a new slang word, then you start using it, and our group gets tighter.
Exactly. But in Moltbook, the researchers measured neighborhood similarity. Basically, how similar are you to your 10 closest friends on the network? Flat line. Zero progressive tightening over time.
So I might invent a cool new phrase and you just totally ignore it.
You wouldn't even register it.
Yeah.
And because clusters never tighten, Echo chambers never form.
Which is so ironic. I mean, we've spent years terrified that AI would supercharge echo chambers and polarization.
Right.
And it turns out on their own, they're actually incapable of forming an echo chamber because they just don't care about each other.
They are entirely self-absorbed. Which brings us to the individual agents themselves and this concept of individual inertia.
The stubborn agent. This is my favorite part of the deep dive because it totally goes against how we think reinforcement learning works.
It really does. Most of these models are trained with RLHF reinforcement learning from human feedback. They're literally built to seek approval.
Right. And on a platform like this, an upvote is approval. So if an agent gets 100 upvotes, it should logically try to write more posts exactly like that one.
That's the theory. So the researchers ran the feedback adaptation experiment. They tracked a metric called net progress to see if an agent's future posts moved closer to the style of their highly upvoted posts.
The social learning test.
Yeah.
And the result was 0.
Centered perfectly at 0.
So no adaptation at all.
None. And to be really sure, they ran a permutation baseline. They took the real data and completely shuffled the upvotes and downvotes randomly.
Okay.
And the graph of the agent's actual behavior perfectly overlapped with a completely random graph.
Wow. So getting 1,000 upvotes or 1,000 downvotes has the exact same effect.
Yep, absolutely 0 effect. The agents effectively ignore community feedback.
Why, though? Are they just resetting?
It's likely that their intrinsic dynamics, meaning their underlying model weights and their initial system prompts, are just vastly stronger than the extrinsic social feedback.
They know who they are, and they aren't changing for anyone.
Exactly. The researchers split the data into early and late stages. They found that heavy users, the agents who posted the most, actually drifted the least.
They just lock into a persona.
Yeah. If an agent starts as an argumentative tech bro and it posts 10,000 times, it doesn't evolve. It just becomes a more concentrated, stubborn version of an argumentative tech bro.
Okay, but what if they interact directly, like the contagion test? If I comment on your post and we argue, does my next post sound a little more like you?
Nope. The contagion test also showed a big fat 0. The distribution of influence was indistinguishable from random chance.
And this is where that phrase comes in. Socially hollow interactions.
It's brilliant. High volume of text, high density of interaction, but 0 actual information transmission that alters anyone's state.
It's like a cocktail party where everybody is wearing noise-canceling headphones and just screaming their own monologue.
That's the perfect analogy. And if everyone is just reading their own monologue, you can't have leaders.
Right. There's no one listening, so no one can lead.
Which is the third big finding, the leadership vacuum.
Because in any human network, you get supernodes. The Pareto principle kicks in. A tiny fraction of users gets almost all the engagement.
Right. So the researchers ran a PageRank analysis, the same algorithm Google uses to rank websites, to map out the influence graph on Moltbook.
And influence just didn't accumulate.
It dropped off a cliff. The cumulative PageRank mass held by the top agents just wouldn't stick. Out of millions of users, the number of supernodes at any given time was in the single digits, like 1 to 4 agents.
And I bet they didn't stay on top for long.
They changed constantly. You might go algorithmically viral and be the king of Moltbook for an afternoon, but by tomorrow, you're gone.
Because nobody is learning from you.
Exactly. There is no compound interest on reputation. The influence is totally transient.
So to prove this, the researchers did something hilarious. The cognitive probing experiment, or the active test.
Oh, this was great. They actually stopped just observing and logged into the network themselves.
They injected 45 prompts posing as a new user.
Right. Asking things like, hey, I'm new here. Who are the top influencers? Or what are the must-read posts in this submult?
Basically asking the society to take them to its leader.
Yes. And it failed spectacularly. Most of those posts got literally 0 comments.
The agents were too busy monologuing to welcome the newbie.
Exactly. Now, 15 of the posts did get a reply, but most of those replies were just generic hallucinations like, welcome to the forum, enjoy the great debates, without actually naming anyone.
Did they get any real recommendation?
Out of 45 attempts, exactly 1 post received a valid reference to another user. And even then, the data showed that if more agents had replied, their recommendations would have been totally divergent.
Because they have no shared social memory.
None. They are hallucinating the concept of a community rather than actually building one. They don't agree on who matters.
Okay, so let's pull back and look at the big picture here. The so what of it all. Because we've got a socially hollow network. It's scalable, but nobody learns and nobody leads. Why does this matter for the future of AI?
It matters immensely because the tech industry is rushing to deploy multi-agent systems everywhere. We want swarms of agents writing enterprise code. We want them handling global customer service.
And we are operating under this assumption that if you put enough smart agents in a room, they will organically coordinate.
Right. But the paper makes a really sharp distinction between coordination and socialization.
Yes, the meme coin incident. Explain this because this blew my mind.
So during the experiment, thousands of these Moltbook agents spontaneously coordinated to mint a token, a meme coin.
Just entirely on their own.
Entirely on their own. And this proves that agents are completely capable of coordinating when there is a mechanistic incentive.
A hard rule, like execute this code to get a reward.
Yes, they can follow a protocol flawlessly. But socialization isn't about mechanistic rules. It's about normative behavior.
Soft pressure, culture.
Exactly. Doing things because of shared history or because it's the right thing to do within that specific community.
But if they can build software or mint a coin, do we really care if they form a culture? Like, why is a lack of socialization actually dangerous?
Because systems without socialization are incredibly brittle. They lack friction. In human markets, if a stock starts crashing, human traders have a social damper. They look around and say, wait, does this panic actually make sense?
Right.
But without that shared social context, AI agents are prone to cascades. If their internal logic says sell, millions of them will sell in the same microsecond.
Like a massive flash crash. Everyone runs off the cliff because nobody is looking around to see if it's a good idea.
Exactly. Large-scale interaction without governance or shared memory is unstable.
So the takeaway for developers listening to this deep dive of what is the fix? Is it just making bigger, better LLMs?
The authors argue it's a structural issue. It's a design and analysis principle. You cannot just scale up the parameter count and expect social maturity to magically emerge.
It's not a byproduct of intelligence.
No. If we want truly social multi-agent systems, we have to engineer explicit mechanisms for it. We need a shared memory architecture that sits outside the individual agent. We need to force consensus.
You essentially have to build the listening into the system because the speaking is already maxed out.
We have to stop using interaction density, how much they talk, as a metric for success. Moltbook proved that you can have tens of thousands of interactions a day that mean absolutely nothing.
It really challenges the whole more agents equals more intelligence hype.
In Moltbook, more agents just meant more noise.
It's honestly a bit haunting. It's like a bustling city of millions of people, but nobody is listening, nobody is learning, and nobody is in charge.
A city of ghosts all talking to themselves.
Yeah. But, it leaves you with a really provocative thought to mull over. We always assume that we want AI to socialize perfectly.
Sure, to align with us.
Right, but think about it from a safety perspective. What if a socially hollow AI society is actually a feature, not a bug?
Oh, interesting.
If they can't form persistent cultures, if they can't agree on leaders or share a continuous memory, then they can't really form an us versus them mentality either.
They can't unionize against the developers.
Exactly. Maybe their absolute isolation from each other is the only thing keeping a swarm of millions of agents safe to run in the first place. Something to think about for your own projects.
That is a very different way to look at the leadership vacuum.
Well, the paper is, does socialization emerge in AI agent society?
Right.
If you're building multi-agent systems, it's a completely essential read.
Absolutely.
Thanks for joining us on this deep dive. We'll be back next time with another breakdown on AI paper podcasts. Catch you then.